Good morning. We're on lesson 73 on page 299. And this first factoring kind of problem is called the difference of two squares. Before we do anything with this, I would ask that you write it in descending order. So you rewrite it as x squared minus 4. And you'll notice it's different than the ones that we've had before because it only has two terms. And we know the square root of x squared is x, and we know the square root of 4 is 2. So when you have it, and it's two terms, and they're both perfect squares, it will always factor like this. An x and an x, of course, for the x squared, and the square root of 4 is 2. One of them will be a positive and one will be a negative. And the reason this works is, gosh, that looks horrible, that when you multiply the outer, you get negative 2x. When you multiply the inner, you get positive 2x. And that cancels each other out. So all that you're left with is the x times x is x squared, and 2 times negative 2 is negative 4. So it's called the difference of two squares. So the next one is 49 m squared minus a squared. It's two terms. And we know the square root of each one of them, so it fits that pattern. So that's like this. The square root of 49m squared is 7m. Put that in both positions. The square root of a squared is a. One is a positive, one is a negative. That's all there is to it. Okay, the next one is minus 36a squared plus 25y squared. Okay, I'm going to write it so that the negative is in the middle. So in other words, I'm going to change it and write it as 25y squared minus 36a squared. Okay, we have two terms, and we know the square root of each one of them. So two parentheses. The square root of this is 5y, so that goes in the front. Square root of this is 6a. One is a positive, one is a negative. Okay? All right, next. Minus, and you don't have to copy it in this order out of the book if you look at it. 36x to the 6th, y to the 4th, plus 49a squared. So you could have copied it out of the book as 49a squared minus 36x to the 6th, y to the 4th. All right, so we know the square root of the first one. It's easy. It's 7a. The next one, the square root of 36 is 6. And to find the square root of these other exponents, you simply divide the exponent by 2. So this is going to be 6x cubed y to the second. 6x cubed y to the second. One will be a plus, one will be a minus. Okay, so to find the square root of an exponent that's not just a 2, you divide that exponent by 2. All right, next topic in this lesson is probability without replacement. So if you pull something out, you don't put it back in, okay? So the first part says, an urn contains 3 black, I'm just going to write that for myself, 3 black marbles and 5 white marbles. A marble is drawn at random and replaced. Then a second marble is randomly drawn. Letter A is, what is the probability that both marbles are black? So the first draw is going to be the same no matter what. We have 3 blacks out of a total of 8 marbles. Okay, the first time we put Okay, so we put the marble back in. It wants to know if we're going to get a black one again, so there's still 3 out of 8. Okay? So you just multiply and you get 9 over 64. Letter B says, if the first marble is not replaced before the second marble is drawn, what is the probability that both marbles are black? All right, so first time, it's the same. We still have 3 out of 8. Now what we do is we pulled that marble out. We put it off to the side. We don't put it back in the bag to pick it out again. So we picked out a black marble. If there were 3 to start with, now how many black ones do we have? We only have 2. And on top of that, we pulled a marble out of the total. So we no longer have 8 marbles for the total. We only have 7. All right? And we're going to do another one of these. So hopefully that will help. Here this will cancel, and then you just multiply what's left. So 3 times 1 is 3. 4 times 7 is 28. All right, so when you don't replace something, you subtract 1 from the number that you're trying to get. In this case, it was the black marble, so we'd subtract 1 and make it 2. But you also have to subtract 1 from the total number of marbles. So instead of it being 8, it was 7 for that second try. Okay, next it says an urn contains 4 red marbles and 7 blue marbles. 2 marbles are drawn at random. What is the probability that the first is red and the second is blue if the marbles are drawn with replacement? So with replacement means we're going to put it back in. And it wants to know probability that the first one is red. So there's 4 reds out of a total of 11 marbles times, we put that marble back in. Now we want to pull a blue one. So there's 7. There's still 11 marbles in that bag. So we multiply straight across, get 28 over 121. 4 reds, 7 blues. Letter B says, what is the probability that the first is red and the second is blue without replacement? So the first one being red is the same. It's 4 over 11. That doesn't change. Now we want a blue one. Well, we already pulled a red one out. Okay, that doesn't affect the number of blues. We still have 7 blues in the bag. But we only have how many marbles? Because we pulled the red one out and left it out. So now we only have 10 marbles in the bag. So here we can cancel 2, 5, multiply straight across, 14 out of 55. All right, so let's look at number 1 in your homework. It says, an urn contains 6 purple marbles and 4, purple, pink. A marble is drawn at random and not replaced. Then a second marble is drawn. What is the probability that both marbles are purple? Okay, so in the first place, we have 6 purple out of a total of 10. Okay, we pulled out 1 and put it off to the side, so it's over here. So now there's not 6 purple marbles anymore because 1 is over here. There's only 5. And there's not 10 marbles anymore because 1 is over here. There's only 9. And we can cross cancel and multiply. Oh, the 2's will cancel too. So then we just have 1/3. All right, so that was number 1 in the homework. Okay, so that is lesson 73. That's going to be due on Thursday. I'm going to go ahead and teach lesson 74. It will be due on Friday. So go ahead and turn to page 303. We actually did this last year in pre-algebra, but just as a refresher, it says to write this number in scientific notation. So remember, scientific notation, the decimal has to be after the first significant digit. So we're going to write it as 3.16. And we can't just move the decimal over and not change anything else. So remember, look at this number right here. Is that number less than 1 or greater than 1? It's less than 1. So that's going to tell me that the sign on my exponent is going to be negative. And now we count the number of places that we have to move that decimal. So it's over 1, 2, 3, 4. So times 10 to the negative 4. Okay? The next one, it says to write this number in scientific notation. Okay, well, at first glance you might think, well, it is times 10 to something. The problem is that is not in scientific notation. Okay, that number is actually this number, isn't it? So this number by itself is 3.16 times 10 to the negative 4, and then times this 10 to the negative 7. Okay. All right, well, these are both exponents on a 10. So it's like saying x to the negative 4 times x to the negative 7. We can add the exponents on the 10s. So this will become 3.16 times 10 to the negative 11. All right. Next, it says to write 0.000316 times 10 to the 7th in scientific notation. So there again, it's the same number we did before. We have to write it as 3.16. That gets moved over 4 times. It was less than 1, so it's a negative. Okay, and then it's times 10 to the 7th. So since they're both on 10s, you can go ahead and add the exponents. So we'll end up with 3.16 times 10 to the 7 minus 4 is 3. Okay, then the next one, 47,800. Write that in scientific notation. So remember the decimal goes right here, 4.78. Now, this number is bigger than 1. So the exponent is going to be positive. And this number didn't have a decimal to begin with. So the decimal is always at the end if there is no decimal. So we're going to count over how many places do we have to move that from the end of the number to behind the 4. So that's 1, 2, 3, 4. Because it was a number bigger than 1, the exponent is positive 4. Okay, then we have that same number times 10 to the negative 7. So we will begin by writing this one as 4.78 times 10 to the positive 4, and then bring down the times 10 to the negative 7. So we'll end up with 4.78 times 10 to the minus 7 plus 4 would be negative 3. Okay, and then the last one is that same number, 47,800 times 10 to the 7th. All right, so we'll begin by writing this as 4.78 times 10 to the 1, 2, 3, 4, and then times the 10 to the 7th, that's also there. So we have, they're both positive exponents. We add them. 4 plus 7 is 11. So we get 4.78 times 10 to the 11th. All right, so this lesson is not due until Friday. Lesson 73 is due on Thursday, 74 on Friday. And I will see you on Thursday and teach lesson 75, which will be due on Monday. You guys have a good day.